All right, this is lesson 1.6, residuals, and we have an objective to use residual plots to check appropriateness of linear models. Now you're going to see a lot of examples from 1.5, but modified for residuals because it's really just a continuation of the previous lesson. And in the previous lesson, you would have been given the scatter plot and you would have needed to draw, a line of best fit. Let's just say that's what it looks like. Not a bad line, all right? When you draw a line of best fit, though, we need to start finding ways to go, is this a good line of best fit, right? Like, our data is scattered all over the place. There's a difference between the actual values and the predicted values. How can we really tell, is this line of best fit a good one? And that's where we start getting into residuals. So a residual is the difference, in fact, I'm right over here, the difference between the actual data value and the predicted value. So the E is going to be your variable for residual. Just kind of like R is for correlation coefficient. The Y is your actual value, okay? And when I'm saying actual value, I'm talking about these green points here. They're the ones that really happened, not the predicted ones. And then this Y up caret here, kind of looks like that, right? This is your predicted value, okay? Now, to get the residual, we really are just taking the Y value and the actual Y value and subtracting the predicted value. So it's nothing too crazy, okay? But once we have that, in order to determine if it's a good model, we need to make what's called a residual plot. That is a graph that shows the residual values on the vertical axis and the independent variable on the horizontal axis. So we're basically saying that the X, which is always our independent variable, whoa. That's unfortunate. Okay, so the independent variable goes on the horizontal line and the residual goes on this vertical line here, okay? We're not really concerned with anything to the left, just to the right, right? And you would, you put numbers here, right? And then you put numbers out here to measure the residual, and you might get graphs that kind of look like all scattered over here, okay? Now, if you're super confused on what a residual plot is at this point, that's okay. This is more of just a big ideas page of what we're going to be doing, and we're going to get into the bread and butter of it next. Okay. Now, let's just look at, if we were to make a residual plot, what would it be telling us? And we have three situations. We have a good model and a strong fit. We have a good model and a weak fit. And then we have a bad model. A good model, strong fit, and a good model, weak fit are really close, but they should stand out. Okay, and what I mean by that is, here's what a good model, strong fit is probably going to look like. All right, now mine was very, one above, one below, one above, one below. Not necessarily needs to be that way. You could have a couple above in a row, but you can tell they're really, really close to that x-axis, and that must mean that the actual value and the predicted value are really close. Okay, so that's what gives us the strong fit. A good model, weak fit, might still jumping around. Maybe a couple are close. But you got some far ones, right? Believe it or not, while if we were doing correlation, we would have been like, oh, these are all scattered, there's no correlation. But this only tells us the distance between the points. And something like this is still a good model. It's still bouncing around that predicted line and staying with it, but it's just a weak fit, okay? Now the last one's a bad model. And this is where you start to notice really interesting patterns here. Okay, that looks like a quadratic. It's not a quadratic. It has that parabola shape though, right? You got to remember that this is not a real X and Y graph. This is a residual plot. And what this would mean is if I had a line of best fit that looked like this, my data points were up here, and then they went below my predicted line, and then they came back. Kind of like a quadratic, but not exactly. That means my predicted is nowhere near close getting these actual values, okay? So if you start to see patterns like that, That's a bad model, okay? All right, here's one for you guys to try. Obviously, it's blank, so I'm going to put some in. What would you say this is? Is this a good model, strong fit, good model, weak fit, or a bad model? Why don't you give it a try? Okay, so hopefully you tried it at this point, and hopefully your answer was this is a good model, weak fit. Okay. All right. Now here's the only concept we will be looking at today. Okay. This is a previous problem that we saw in 1.5 where we had to create a line of best fit and get that predicted value, right? And that was referenced with this line of best fit. Okay, so we've already done that work. What we want to do now is create a residual plot for it in that space to the left, okay, and get into the nitty-gritty of how we do this. So first things first is you're going to want to create kind of a table for this, all right? Now, you don't have to use a table, but I highly recommend it because we have a lot of values and it's going to take a little bit of time. So the first one you're going to have is your x values. The next one you're going to have is your y. Then you're going to have your predicted y values. And then you're going to have your residual, so which is e equals to the actual minus the predicted. Okay, and then that's right here, whatever goes here, is what's going to be plotted on our residual plot, but we have to find that first. And at this point in time, we don't even have our predicted values. We have a line of best fit that could tell us what those predicted values are, but we need to find them. Okay, the only values that we have up until this point is the x and y values, right? Which here they really referenced as t and p of t. Okay. So whatever variables they use, you want to pay close attention to those. Now we're not going to do all 12 for the sake of brevity, but let's do the first 8. Let's do the first 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And we already have y values for those, right? We have 3.0, 2.5, 4.0, 5.0, 6.5. You guessed it, 5.5. And then 7.0, and then 6.0. Okay? Now, those are given. Let's get the predicted. The way we get the predicted is we take our x values, plug it into our line of best fit. Whatever we get out becomes our predicted values. Now, if you look at this, 0.625, right? Use your calculators. 0.625 times 1 equals 0.625 plus 2, and we get 2.625. Okay? Now, I'm going to test out some fast forwarding here so that you don't have to listen to me plug all these in. So I'm just going to plug them in. Okay, so caught some errors there. I forgot to add 2 at the end of those. Good thing I fixed them before you guys corrected me. And we get all of those predicted values. All right. Now the next thing you're going to have to do is this part on the right, the actual minus the predicted. And you can kind of read that just the way we see it, right? 3 minus 2.625, 2.5 minus 3.25. And, again, it's a little bit of time. Use your calculator. I'll do the first one before fast forwarding. We get, there we go, 0.375 positive. And then keep going. Okay, so, again, we got these values by plugging x into our line of best fit, and then we got our residual values by taking the actual and subtracting it by the predicted, okay? Now, once you have this, you need to go to your residual plot and plot it out. So I have on here will be x, here will be e, and our highest e value is 1.375, and our lowest negative doesn't even break -1, but we want it to match. So I'm going to put, let's go back over here. Let's do, 0.5, 1, 1.5, and then -0.5, -1, -1.5, okay? And then we have 8 numbers, right? So 1, 2, 3, 4, 5, 6, 7, 8, okay? And I'm just going to do the best that I can to graph these. So at x is 1, it was 0.375, so that's probably right here. Then at 2, we're at -0.75. 3, 0.125, a little bit above. Then 0.5, a little bit higher. Sorry, let me make these a little bit more prominent. And then 1.375 is a little bit higher. And then we're down to -0.25, and then 6.25, and then -1, okay? And this is what a residual plot be. Obviously, we have a couple more up to 12, but for brevity's sake, I think that was enough, all right? And the final question we would really want to ask ourselves is this a good fit, okay? And I would say this is a good fit. And it would be really tough to say here if it's a strong fit, but really think about that for a second. We're 1 away based off these numbers here. We're getting up to 1 away, maybe 1.5 away. If we think about that, what that value actually means, you're talking about thousands of dollars, right? So I would say good fit, or good model. Sorry, I wrote that all backwards. Good model. Weak fit. I want something a little bit closer for strong fit. I wouldn't want thousands of dollars to be my margin of error, okay? All right, now you guys have a problem here. It's a little bit shorter of one. I want you guys to pause and give it a try. Oh, and by give it a try, I mean, create a residual plot. Okay, hopefully you gave it a try, all right? And hopefully you started off by making not a poorly drawn table, just a table. Okay. So you should have started off by doing something like this, right? You have your x, you have your y, you have your predicted y, and you have your e, okay? Now this one was a little bit shorter, thankfully, okay? But in the previous problem that we did this, meal cost was our x and tip was our y, okay? And so we have our x of 4.75, 6.84, 12.52, 20.42, and then 8.97, okay? We had our actual ones, so 0.5, 0.9, 1.5, 3, and 1. And we needed to get our predicted, so I'm going to plug that into my calculator. Remember, we're taking x and plugging it up here, and that y we get out goes there. So that would be 0.17 times 4.75 minus 0.5. Okay. And I ended up with 0.3075. Is that right? Let me just do that one more time. Yep, that's right. Okay, and then I'm just going to quickly plug these in and see what I get. Okay, so again, you could have rounded at a lot of these points here, right? And I highly recommend doing so, but because I'm leaving things in a calculator, I tend to just leave it all because it's not too much extra work, okay? So now we're going to take the actual minus the predicted, okay? So the first one is 0.5. That was it, right? Yeah, 0.5 minus 0.3075. And so here I'm going to round 1.19. Okay, and these were the residual values I got: 0.19, 0.24, negative 0.13, 0.03, and negative 0.02. So already you can tell not much margin of error there. Those residuals are really small values, okay? So we're going to go and plot. We got x, we have our e, and our highest value doesn't even get to, a half, right? But I'm just going to put, 0.5 and negative 0.5 there, okay? Hard to kind of see. Let me redo that. So negative 0.5 would go positive 0.5. And then negative 0.5 would go like that, okay? If I used 1 at that length, it would just be really, really close. And so then we had really 5 x's, okay? But they're at different values. So we have 4, 6, 12, 20, and 8. And that's kind of crucial there. Just because this is our 5th point that we plugged in doesn't mean it should be the 5th point we plot, right? We still need to honor the appropriate x values. So our highest x value is 20, so maybe we should go, by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So this ended up being 26, okay? And I need to go and plot. So at 4.75 and we have 0.19. So that's really low. So that's about like here, okay? Make these points a little bit bigger. And then at 6.84, which is not much further than that, we have 0.24, so that should be a little bit higher. Then at 12, so keep in mind this would be 10. At 12.52, we have negative 0.3, so that's really close. And then finally, almost, at 20, which is there, we have 0.03, so it's basically on it, right? And then 8.97. 8.97 would be really, really, well, it should be a little bit more to the right, like somewhere like there, okay? Those are all really, really, really close, right? So if we were to ask if this is a good fit, we would say this is a good model and a strong fit. I mean, our points are almost spot on. We're only off by some cases 2 pennies in predicting what the tip would be for a certain meal cost. So that's really good. So I hope you guys learned something in this. It was a really long video, lots of explanations, lots of plugging in. Hopefully I can figure out how to fast forward through all those times of me calculating.